February-March 2019, variant 3.3. It's about the determination of whether water of crystallization is present in the basic copper to carbonate sample or not by gravimetry. Question says, it is possible that ores containing basic copper to carbonate also contain water of crystallization. The formula of these ores would be written as X copper to carbonate, Y copper to hydroxide. This means the basicity. Basic copper to carbonate is because of this. Water is present or not, we are going to determine now. In this experiment, you will heat a sample of different basic copper to carbonate, which will thermally decompose as shown. So when it decomposes, copper to carbonate also, copper to hydroxide also, gives off copper to oxide, carbon dioxide and water. These two will be released in the form of gas and just copper to oxide will be remaining as solid. You will use your results to determine whether this sample of a different basic copper to carbonate contains water of crystallization. Fa3 is a sample of different basic copper to carbonate. Apparatus and chemicals given are a burner with a tripod stand and a pipe clay triangle with green crystalline solid in a test tube, a pair of tongs and a crucible with lid on a heat-proof mat, then a lighter. Method: weigh the empty crucible with its lid and record the mass. Crucible with the lid, 32.02 grams. Crucible and its lid, 32.02 grams. Add all the Fa3 to the crucible. Reweigh the crucible, lid and Fa3. Record the mass. Now let's transfer this Fa3 into the crucible and record the mass of crucible with lid and Fa3, 34.32. Mass of crucible, lid and Fa3 is 34.32 grams. Next, support the crucible in a pipe clay triangle on the top of the tripod. Remove the lid and then heat the crucible gently for 1 minute and then strongly for about 4 minutes. So let's do it now. Now let's support this crucible on a pipe clay triangle like this first. Then place this triangle correctly on this tripod stand and then remove the lid and start heating for 1 minute. As soon as we start heating, we will start the timer. Now, heat gently means you have to keep the flame as low as it only touches the bottom of the crucible. It's 1 minute, so we will increase the flame so that crucible is heated from all the sides, which is meant by strong heating. As soon as timer says 5 minutes, we will stop our Bunsen burner flame. And now let's have a look at the appearance. It's totally converted into black solid. After heating for 5 minutes of total time, replace the lid and allow the crucible to cool. Now once you want to remove this crucible, you will use this pair of tongs because it's hot or you might get your fingers burned. You will hold like this from the wall. You will take this to the heat-proof mat, and then you will replace the lid and allow it to cool down. Now, when the crucible has cooled, reweigh the crucible lid and condense, record the mass. Now, let's reweigh the crucible when it's cool with the lid. 34.15. The mass of crucible and the lid with the condense 34.15 grams. Then calculate and record the mass of Fa3 used, which can easily be calculated by subtracting these two values, the crucible and the lid, and the crucible with lid and Fa3. So once we subtract these two values, we will get the mass of Fa3 used. Then the mass of residue, and the mass of residue can be calculated by subtracting this value with the only crucible and the lid mass. Then the loss of mass. So the two calculated values, Fa3 used and the residue remaining, when we subtract these two, we will get the loss in mass. So let's record all the observations and readings in this space provided. So all the observation of masses are recorded in a form of proper table. While drawing this table, remember to write the masses in this way: mass of crucible plus lid in grams, then mass of crucible and lid plus Fe3 before heating in grams, then mass of crucible plus lid plus residue which is left after heating in grams. In this way, you can easily calculate the mass of Fa3 used. How? By subtracting the mass of crucible and lid from this, which is the first value. So subtract the first value from this value, you will just get the mass of Fa3 used. And when you are to calculate the mass of residue, you can just subtract the mass of crucible and lid from this mass. You will get the mass of residue only. Then after subtracting these two values, the mass of Fa3 used and residue, you will get the mass lost. So this is easy way of remembering and calculating all the values. Now let's move on to the next part, which says calculations. Assume the percentage by mass of copper to carbonate in Fa3 is 60%. Calculate the mass of copper to carbonate present in Fa3. So if we look at the mass of Fa3 on the previous page we have used, it was 2.30. So if you want to calculate 60% of this, what we can do is 60% of Fa3, which is 2.30. So the mass here will be 1.38 grams. From here, we need to calculate the moles of copper to carbonate in Fa3. We got the mass of copper to carbonate, and we can use this to calculate its moles. So mole is equals to mass in grams divided by the MR of compound. Well, in this case, the mass is 1.38 grams divided by the MR of copper to carbonate is 63.5 is copper, carbon is 12, again 1, and oxygen is 16, which is 3 times. So the MR of this compound, if we divide, we will get the moles, which is 0.01117 up to 4 significant figures. The next part says use your results from A, which is the table, of course, this is B. Calculate the number of moles of copper to oxide formed on heating Fa3. So now, if we look at the previous page, here the mass of residue left is 2.13 and the residue is only copper to oxide. Therefore, the moles of this copper to oxide can be calculated by dividing this mass, which is 2.13 with the MR of copper 2 oxide, which is 63.5, and 16 is the copper 2 oxide. So the moles of copper 2 oxide left 0.02680. Four significant figures here again. The next part says use your answer to 1 and 2 and the equation on page 5 to calculate the moles of copper 2 hydroxide in Fe3. Now, if we look back at the equation, it says copper 2 carbonate is X moles and copper 2 hydroxide is Y moles. And the copper oxide formed is the sum of X and Y. So if we subtract the moles of X from this, we can get the moles of Y. Therefore, the moles of this copper 2 carbonate we got and the moles of copper oxide we got. If we subtract these two values, we can get the value of Y. So we will subtract the part 1 answer, which is copper 2 carbonate moles, part 1, and part 2 answer, which is copper 2 oxide, to get the moles of copper hydroxides. Therefore, 0.02680 minus 0.0117. So here the answer will be 0.01563 moles. Moving on to the next part, part 4, it says use your answer to 1. Calculate the mass of carbon dioxide produced by the thermal decomposition of copper 2 carbonate in Fe3. So if we look at the equation of copper 2 carbonate being thermally decomposed, it will give you copper 2 oxide and carbon dioxide in 1:1 ratio. So in part 1, the moles of copper 2 carbonate given were 0.01117. Therefore, if we have 0.01117 moles of copper 2 carbonate, how much of carbon dioxide we can get? 1:1 ratio. So same moles of carbon dioxide will be obtained. Now this is the mole and they have asked us to find the mass. Therefore, the second formula we are going to use here is mole is equals to mass in gram divided by the MR of carbon dioxide. So moles here are 0.01117. To calculate the mass, we need to divide by the MR of carbon dioxide, and carbon dioxide has 44 MR. So the mass of carbon dioxide given off is 0.491 grams in this case. Now let's move on to the next part, which says use your answer to part 3 to calculate the mass of water produced by the thermal decomposition of copper 2 hydroxide. So if we have copper 2 hydroxide here, and if we want to see the thermal decomposition equation for any hydroxide of copper, it will form copper 2 oxide and steam in again 1:1 ratio. Therefore, the moles of copper 2 hydroxide here 0.01563 moles will give you the same moles of water. Again, to calculate the mass, what we will do, mass is equals to mass in gram of water is equals to moles, which are 0.01563, multiply by the MR of water, which is 18. So the mass calculated will be 0.281 grams. Now the next part says deduce whether the water of crystallization is present in basic copper 2 carbonate Fe3. Justify your answer using your results from A and your results to part 4 and 5. Now the part 4 and 5 shows the total mass lost, that is carbon dioxide and water in the equation. So if we calculate the total mass lost theoretically what we have calculated is 0.491 in part 4, and in part 5 it is 0.281. So altogether the total mass lost is 0.772 grams theoretically. However, if we look at the part A, where they have said in the table the total mass lost was 0.17 grams. So the actual loss in mass was actual loss in mass was 0.17 gram. Now if we look at these two values, 0.772, theoretically the mass loss is a way greater value than the actual loss in mass. Therefore, basic copper 2 carbonate does not contain any water of crystallization according to our calculation. So we can justify that 0.17 gram is lesser than the theoretically 0.772 grams loss. Therefore, water of crystallization is not present in our sample. Of Fa3. Now let's move on to the next part, which says C1. The lid was replaced before the crucible was cooled. Explain how replacing the lid before the crucible was cooled may have increased the accuracy of your results. So if we replace the lid, what happens is the cooling of crystals will not absorb moisture or water vapors from the atmosphere. That is why our accuracy in measuring the mass after heating will increase. So we will write here, prevents the absorption of water vapors from the atmosphere. For 1 mark. The next part says, using the same apparatus suggest an improvement to the method to increase the accuracy of your results. So now, if we look at the mass we have used in the previous part, the mass of Fa3 used was 2.30. So if we want to calculate the percentage error, so 2.30 mass will give you the value of percentage error according to the formula. Percentage error has a formula. Error of device divided by the measured value. Percentage error is calculated this way. Error of device divided by whatever value you measure there, measured value, into 100. So if we look, we have used here the measured value 2.30, and the percentage error is inversely proportional to this value. So if we use a larger value, the percentage error will be reduced. Therefore, we will use the larger mass of Fa3. Use larger mass of Fa3. This is one of the improvement. And the second is, if we reheat the content, because we have not reheated. If you look at the table, we have just heated once and we have calculated the value. We haven't removed completely whatever could be removed from the salt, like whatever water or carbon dioxide can be lost. We haven't done it. We have just heated once. Therefore, we can also say reheat the content till constant mass. So to reduce the percentage error, and we can also write here reheat the contents till a constant mass. Just one you can write here. Now the next part says a student carried out the method in A and obtained inaccurate results. The student suggested that not all of the copper 2 carbonate in the sample of basic copper 2 carbonate Fe3 had thermally decomposed. Suggest a chemical test to determine whether the student was correct. Give the expected observation. Do not carry out this test, but just tell us what could be done. So if you think about this statement that not all the copper 2 carbonate in the sample decomposed, it means some of the copper 2 carbonate is there in the compound. So if copper 2 carbonate is present in any substance, or if there is any carbonate present in any of the compound, what you can do is you can add any acid. You can use any acid, HCl, HNO3, H2SO4, whatever. If you add any acid reacts with metal carbonate and it gives off carbon dioxide and water. Therefore, what we can say here is add dilute HCl or HNO3, and if copper 2 carbonate is left, it means fizzing will happen, and observe fizzing. No fizz if there is copper 2 carbonate completely removed. It means if no fizz indicates all copper 2 carbonate has decomposed. So here we comes to an end of 15 marks question from February-March 2019, variant 3.3 about measuring water of crystallization.